Welcome to Khetz tutorials, and in this video I'll be doing question 72 from the exercises in geometric calculus. So I asked to find all x in this region between 0 and 2 pi inclusive. And to kick us off, this is an identity. It's the double angled identity for cosine, and I have another cosine on this side. So I'd rather use one that, or I'd rather convert this to its equivalent form that only has a cosine, and this is where I'm going with this. So I want to convert this into a quadratic equation. So this replaces that part there. It's an identity conversion. Then I still have everything as it were. And now I'm just going to move stuff around. So I'm going to place this here at the start and just to write them in descending powers of cosine, as if I had cosine is just a variable, as if I have 2x squared minus 3x and then plus 1. Just like that. 2 minus 1 is 1. So this is the behavior which I'm trying to copy. And from this behavior, I can definitely factorize, or from my knowledge of this, or how to factorize this, I can also factorize this. And that's exactly what I'm going to do. If it makes it any easier for you, you can say let k equals cosine x. Then in place of cosine x, you do something like this. Then work on it, solve it. After factorizing, when you get to this point where k equals something, you can substitute this back and then work with that. But if you want to do it directly, you can as well. So here's how I do it. I'm going to look for factors of 2 times 1. So factors of 2 that give me 2 when I multiply, but those factors should also give me minus 3 when I add them. So that's how I do it. And those factors are minus 2 and minus 1. So if you multiply minus 2 and minus 1, you get 2. If you add them, you get minus 3. So I'm going to split the middle term using those factors. So minus 2, minus 1. So just split this into 2 terms, and this is for factorization purposes. So the common factor, so I'm now going to factorize in pairs. The common factor on the left is 2 cosine. It will leave me with cosine here and a minus 1. Factor out a negative here, it will leave me with cosine and minus 1 for these two. And I have that. So these two brackets are common. I can factor those out. And I'm left with 2 cosine minus 1 from there. This is equals 0. I now have cosine x equals 1 or 2 cosine x equals 1. So on this side, this is the same as cosine x equals a half. From this, I can now solve the general solution. So I can now find the general solutions. So first, I'm going to find the reference angle. That will be the arc cosine of 1, which is 0. So my reference angle here is 0. And now I'm going to look at the sign of this number. It's positive. Going back to the cos diagram, cosine is positive there and there. So to represent those regions, I'm going to have x equals 0 plus, which is this direction at A, or 0 minus, which is that point there. So plus or minus reference angle plus the period that I'm going to have multiplied by some integer. Okay, so that is one way. And at that same point, you can also interpret it as 2 pi, I guess. It's totally up to you which one you choose to use, either 0 or 2 pi, because it's the exact same point. So now I just have x equals 2 pi n, where n is an integer. Now let's try some integers that will give us answers between 0 and 2 pi inclusive. The only one I can think of, or the only two I can think of, are 0, which will give me an x of 0, and an n of 1, which would give me 2 pi. Everything outside of those two, or anything to the left or to the right of those, will basically give you something which is either higher or lower than the boundaries 0 and 2 pi. So these are all the answers we can get from this side. Then coming to this side, our reference angle, you're going to use the positive form of whatever number you have there. In this case, we have a half, and that should now give you pi over 3. So that is our reference angle over there. And this is positive, which means once again, we're going to the cast diagram and see where cosine is positive. Once again, it's positive there and there. And that region is described by 0 plus the reference angle plus the period, as well as 0 minus. 0 minus would be this quadrant, multiplied by the period n, and n is an integer. And once again, let's simplify these first. So you just have this is a 0, so you just have these basically. And now you can focus on substituting n values there to then find what the other answers are. So if you here, this is a negative by the way, because one of them is 0 plus, the other one 0 minus. So if you put a 0 here, this is automatically out because it's negative and the lower bound is 0. If you put a 1 in there, you have 2 pi minus pi over 3, and 2 pi with a denominator of 3 is the same as 6 pi over 3. And if you multiply that, you're going to have 5 pi over 3. Right? So that there is one of your solutions which falls between 0 and 2 pi. So that can be one of your solutions. Then if you substitute a 2, you definitely fall outside this region. Substitute a 1, we've already done that. Substitute a 0 is already out. Then here, if you substitute a 0, you're going to have pi over 3, which is within. So you can also give that as your answer. If you substitute a 1, it'll be outside because it's 2 pi plus. So you'll be outside. And if you substitute a negative 2, then you're going to have negative 5 over 3, which is to the left of the lower bound. So these are all the answers that we can get from any combination of the n values in any of these general solutions. So you give these as your final answer.